Hello students. So this is my 6th lesson on complex number. Yeah, it is getting lot of time, but today I am going to solve some past paper questions as well, okay, so that you get some idea about the past papers, okay. If you have any suggestions, if you have any requests about past paper, then please write it in the comment box, okay. If you like my lesson, then definitely please like, share and subscribe my channel, okay. So let us start now. Yeah, so we have already studied what is a complex number, then complex number in a complex plane or argand plane, then modulus of a complex number, then argument of a complex number, distance between two complex numbers, we have seen it, midpoint of a complex number, of two complex numbers, midpoint between them, and transformation of a complex number to another complex number. Similarly, in last lesson we have already studied Euler's form, okay. What is Euler's form? E raised to I theta, okay. So, and de Moivre's theorem also we have studied, okay. And nth root of a complex number, nth roots of a complex number. So whatever fourth roots of fourth roots will be there, 5 roots of 5 fifth roots will be there, and so on, okay. Now in this lesson we will again study nth root of a complex number, because I feel last time I didn't do more of the questions, so I will be revising few things. And then cube root of unity, it is of unity, and some past paper questions definitely. Okay, then let us start. Yeah, so roots of a complex number, already we had discussed it in the last lesson, but again I will revise. So solving z to the power n is equal to c, okay. The nth roots of the complex number c are the n solutions of z to the power n is equal to c, okay. Now those solutions, how they are? There are exactly n nth roots of c. If it is nth root, there will be n nth roots, okay. For example, if it is fifth root, if you want to find, then there will be 5 fifth roots. Then similarly 4 fourth roots, 6 sixth roots, and so on, okay. Then C belongs to R. The complex roots must occur in conjugate pair. Complex roots, when we get, they are always in complex pair, in conjugate pairs, okay. Complex number and its conjugate will be there, okay, always. If C does not belong to R, if C is not a real number, the complex roots do not all occur in conjugate pairs. Some of them may be conjugate pairs, but all of them do not occur in conjugate pairs, okay. So I hope you will remember this, okay. Then the roots of z to the power n will all have the same modulus, which is modulus of c to the power 1 by n. All of them will have the same modulus. Argument will be different. On an argand diagram, the roots all lie on a circle with radius which is equal to the modulus of the complex number. The roots on the circle r is equal to modulus of c to the power n 1 by n will equally spaced around the circle. They will be equally spaced, okay. I will show you today how they are equally spaced. The roots on the circle, they will be equally spaced. If you join the points corresponding to the roots, you will obtain a regular polygon. There will be a regular polygon because they are equally spaced. All sides of the polygon will be equal, and therefore it will be a regular polygon. So let us solve few more questions here, okay. Now here is z to the power 4 is equal to 16. So we want to find 4 fourth roots of this complex number, okay. It is only having real part, but no problem. So I will start with a part. Z to the power 4 is 16. So I can write z is z to the power 4 in polar form is equal to 16, and I can use sys 0 plus k into 2 pi, where k belongs to z. K is an integer. Okay. So I hope you will remember this. This is in polar form. Because from polar form it is easy to find the roots of a complex number. Okay. So therefore z will be equal to 16 sys 0 plus k 2 pi, and here no need of 0 of course. So let me erase that 0. So k 2 pi and all of it raised to 1 by 4. Okay. Then as you know, we have studied it last time that modulus takes the 1/4 power. Okay. So 16 to the power 1 by 4, and sys will have 1/4 as a multiple. Okay. So k into 2 pi by 4, which will be pi by 2. So z will be 2 sys k pi by 2. Now here k is going to take the values 0, 1, 2 and 3. Like that we are going to have 4 roots of complex numbers. So for k is equal to 0, we are going to get first root z1 2 sys, replace k by 0, so it will be 0 only. Okay. So therefore the answer will be 2 only. Okay, because 2 sys 0 will give you 2. Then for k is equal to 1, z2 will be 2 sys 1 pi by 2 is pi by 2. Cos pi by 2 is 0, sin pi by 2 will be 1. So 2i, because sin will have I with it. Then for k is equal to 2, z3 third root will be 2 sys 3 pi by 2, k will be replaced by 3, and 3 pi by 2, where it will be on the negative imaginary axis. So therefore you will get negative 2i. Okay. And for k is equal to 3, z4 will be 2 sys, when you replace, here I should have replaced in the first place by 2. Yeah, so it will be, k will be replaced by 2. So 2 pi by 2 is pi, and pi will be minus 1, because cos pi is minus 1. So 2 into minus 1 will be minus 2. The last one will be 3 pi by 2. So now this will be on the negative imaginary axis, therefore minus I, so minus 2i. So look here, they are in the conjugate pair. Okay, complex number and its conjugate, then 2 and minus 2. Now suppose if you want to plot them on a complex plane, how they will be. Let me show it to you. So I'll show you here. Real axis, imaginary axis, origin, and there will be a circle whose radius is 2 units. Okay, let this circle have 2 units. Now the first one is, look here, first one is 2. So it will be located on the real axis, which will be 2. Okay, so look here, this 2 will go there. Then as we have discussed just now, the properties of the nth roots, that they are equally spaced. Okay, then second will be 2i, which will be on the imaginary axis, 2i. Okay, so this one has gone here on the imaginary axis. Third one is again minus 2. So as we said, it is equally spaced, so it will be opposite of 2. And the last one is minus 2i, so it will be here. So look here, minus 2i has been there, minus 2 is here, 2i is here, and 2 is here. So they are equally spaced, right? Okay. So like this you can represent them. Okay. I will solve the second question, B part. Z to the power 4 is equal to minus 16. Where is it? Oh, I have to copy it here. Yeah, here I will start this. Now z to the power 4 is negative. Okay. And when you write it in the polar form, minus a real number means cis pi only, because cos pi is minus 1, sin pi is 0, so we don't have the imaginary part. So therefore z to the power 4, okay, I can write as 16 cis pi plus k into 2 pi, where k belongs to z. This is in polar form. Okay. Therefore, z will be 16 cis pi plus k into 2 pi to the power 1 by 4, right? Because we want to find 1 by 4th roots. So 16 will take that power 1 by 4, and cis will get multiplied by 1 by 4. So pi by 4 plus k into 2 pi by 4. Okay. I'll keep it as it is because both will have the same denominator 4. So it will be easier for you to simplify. So 2 cis, okay. It will be, because it is negative, so it will be 2 cis pi by 4, 2 cis pi by 4 plus, let me write it first, k into 2 pi by 4. Okay, now for what k is going to take the values, where k is going to take the values 0, 1, 2, 3. Like that we are going to get 4 roots. Okay. So k is equal to 0 implies your first root will be 2 cis pi by 4 only, because k is 0, and we know that pi by 4 is 1 by root 2 plus I into 1 by root 2. When you multiply by 8, it is going to give us root 2 plus root 2i. Okay, this is the first root of this complex number. Okay, then the second root will be k is equal to 1, z2, 2 cis. Look here, I am replacing k by 0, then 1, then 2. So when I replace it by 1, I will get pi by 4 plus 1 into 2 pi by 4. So 2 cis, 2 and 1, 3 pi by 4. Now 3 pi by 4 is in the second quadrant. So the answer will be 2 into minus 1 by root 2 plus I into 1 by root 2. Because in the second quadrant, cosine will be negative and sine will be positive. So final answer is minus root 2 plus root 2i. Okay. This is the second root. Then for k is equal to 2, I am going to get the third root. So 2 into cis, okay. Again, this k I am going to replace by 2, okay. So 2 to the 4, 4 pi by 4 will be pi. So cis pi by 4 plus pi. Now look here, according to the rules of polar form, you already know that polar form takes angle between minus pi, and the argument of polar form is between minus pi and plus pi. Okay, so therefore it is in the third quadrant now, and in the third quadrant what we write? We write pi by 4 minus pi, because pi by 4 is the angle, so we are going to write pi by 4 minus pi, so which will be minus 3 pi by 4, right? Yeah, is that clear to you? Okay, so I am going to write here 4 pi by 4 plus pi. I can write pi by 4 minus pi, because I am coming from the negative side. I am somewhere here, so I should write this angle. Okay, so minus 3 pi by 4. Okay, so 2 cis minus 3 pi by 4, and in the third quadrant both of them are negative, so negative 1 by root 2, negative 1 by root 2 I, and finally it will be negative root 2, negative root 2 I. Okay, so both of them will have the negative sign. And for k is equal to 3, z4 the fourth root, 2 cis pi by 4, and look here, there was k here, so that k will become 3, so 3 times 2, 6 pi by 4. So this is going to become 7 pi by 4. Now look here, where is 7 pi by 4? Okay, so 7 pi by 4 is in the fourth quadrant, right? 7 pi by 4 is somewhere in the fourth quadrant, right? So it will be this minus pi again, because in the third and the fourth quadrant we write angle minus the argument minus pi, so it will be minus 3 pi by 4. Okay, so 2 cis minus 3 pi by 4, and in the fourth quadrant cos is positive, so 1 by root 2, sine is negative, so minus 1 by root 2 I, finally it will be root 2 minus root 2 I. Okay, so like that I got all the 4 roots. I will need one page to show you on the complex plane. Okay, so I will add one more page here. Yeah, so therefore this is all of them. I will draw it here. Wait, and the circle. Yeah, this is the real axis, imaginary axis, origin. What will be the radius of this these roots? It will be 2, right? Again. So what are my answers? My answers are 2 root 2 I. First one is 2 root 2 I, which will be here, root 2 plus root 2 I mean. Then second complex number is minus root 2 plus root 2 I, so which will be here in the middle. Then third one is both negative, here in the middle, minus root 2 minus root 2 I, and the fourth will be here, root 2 minus root 2 I. So look here, they are equally spaced. Okay, and each pair is in conjugate. So conjugate of this is this one, and conjugate of this is this one. Okay, they are in conjugate pairs. Okay then, so I hope you understood this. Okay, now next question is solve the following and display solutions on the Argand diagram. I have already started showing you on the Argand diagram, right? So let me start with A part. z cube is 2 plus 2i. So how can you write it? So its argument is 2 in square root of 8, which will be 2 root 2. So therefore I can write z cube is equal to 2 root 2, and in the polar form says what will be theta for this? Pi by 4, right? Plus k into 2 pi, where k belongs to z polar form. Okay. From polar form it is easy to find the roots. So therefore z is equal to, we will take 1/3 power cis pi by 4 plus k into 2 pi bracket to the power 1 by 3. So 2 root 2 will have the power 1 by 3, and cis will get multiplied by 1 by 3. So pi by 12 plus k 2 pi by 3, okay, because 4 times 3 it was 12. Now for convenience we will make both of them denominator will be 12, okay, and 2 root 2 cube root of 2 root 2 is root 2. So cis I will write pi plus k, I'll multiply numerator and denominator by 4 here, okay. So 4 to the 8, 3 for the 12, so that both will have the same denominator. So it will be easy for us to calculate. So I will give it number 1. Now for k is equal to 0, I will get the first root z1 root 2 cis pi only, and pi is minus 1, you already know about it, okay. So it will be minus root 2, right? Okay, so this is the first root 2. But here, look here, I will put minus 1, 0 and 1, because I should make them equally spaced. So no problem, 0 I found now. So I will find k is equal to minus 1. So z2 will be root 2 cis pi, and in 1 I will replace k by minus 1. So minus 8 pi by, sorry, this is pi by 12. Here I have to replace, okay, and here, sorry, I forgot to write here 12. Oh, this was 12 also, sorry. This was also 12. Yeah, because I copied it wrong. So it should be pi by 12. First one. Then pi by 12 minus 8 pi by 12, which is going to give me root 2 cis 1 minus 8 minus 7 pi by 12. Right? Minus 7 pi by 12. So minus 7 pi by 12 to 210 divided by 2, it will be in the second quadrant. Minus 7 pi by 12. It will be, where it will be? Okay, let us write it like that only. Okay, it will be in the third quadrant, and k is equal to 1 I will take. So z3, my third root will be 2 root 2 cis pi by 12, and this k I will replace by 1. So it will be plus 8 pi by 12, and it will be cis 9 pi by 12. Okay, 9 pi by 12. Now 9 pi by 12 I can simplify. Okay, so 9 pi by 12 will become, see, 9 pi by 12 will be Yeah. So 9 pi by 12 will be, I will divide it by 3. Okay. So cis 3 pi by 4. And 3 pi by 4 you already know. 3 pi by 4 is in the second quadrant. So root 2 minus 1 by root 2, right? And plus I 1 by root 2. So root 2 will cancel. 1 minus 1 plus I will be my third root. Okay. So now if you have to plot them, they are equally spaced. As I said, let me draw them and then I will start the next question. Let me show them on the complex plane. Yeah, so this is real axis, origin, imaginary axis, and this root, okay, will be root 2 cis pi by 12. And the next one will be cis root 2 cis minus 7 pi by 12. Okay, and the third one we already got here, minus 1 plus I. So like that they are equally spaced. Okay. Okay, then the next one is z cube is equal to minus 2 plus 2I. Okay. So when we write it in the polar form, what is the argument of it? 2 square 4, 2 square 4. 4 and 4, 8 means 2 root 2. Okay. So it will be having argument 2 root 2. So 2 root 2 and cis. Look here, theta will be tan inverse negative 1, which will be minus pi by 4, right? But in the second quadrant we will write 3 pi by 4, okay? Not minus pi by 4, of course. So I'll write 3 pi by 4, okay? Cis 3 pi by 4 plus k into 2 pi, where k belongs to z. This is in polar form, okay? So therefore z will be equal to 2 root 2 cis 3 pi by 4 plus k 2 pi by 2 pi bracket to the power 1 by 3, okay, which will be root 2, because 2 root 2 cube root of 2 root 2 is root 2, and cis will get multiplied. So cis 3 pi by 12 plus k 2 pi by 3, okay, but we want to make both of them same like the last question. So root 2 cis 3 pi by 12 plus k 8 pi by 12. I am multiplying numerator denominator here by 4, okay, 4 into 2 8, 4 into 3 12. So like that this becomes like this. Now we have to replace k is equal to minus 1, 0 and 1, because we want them to be equally spaced. So k is equal to minus 1 will give me the first cube root. So root 2 cis 3 pi by 12 only, because 3 pi by 12 minus 8 pi by 12. So this will be root 2 cis 3 minus 8 minus 5 pi by 12, okay. Minus 5 pi by 12 is in the fourth quadrant, so we will keep it like that. Then k is equal to 0 will give me z2 is equal to root 2 again, cis 3 pi by 12, and k will be replaced by 1, by 0, so nothing will come here. 3 pi by 12 will remain as it is, but this 3 pi by 12 Okay, when I put 0, 3 pi by 12 will be pi by 4, right? We can divide by 3, so pi by 4, and pi by 4 is 1 by root 2 plus I 1 by root 2. So both the root 2 will cancel, so 1 plus I, okay, second root, and k is equal to 1 I will substitute, so z3 third root, root 2 says, now here k will be replaced by 1, so therefore 3 pi by 12 plus 1 8 pi by 12, so 11 pi by 12 it will be, okay, and 11 pi by 12 is in the second quadrant, so we will keep it as it is. So like that we got 3 cube roots of z, and I want to plot them here. Yeah, so real axis, imaginary axis. Now first one, 1 plus I, this 0, the middle one is here, 1 plus I, from origin it will be connected like that, okay. Then minus 5 pi by 12 will be in the fourth quadrant somewhere here, so root 2 says minus 5 pi by 12, okay. So this one has been taken here, this one is taken here, and the third one means the first one, the third one will come somewhere here because they are equally spaced. So, or maybe I should put it like that, then it will be correct. So here root 2 cis, I should write cis with it, I forgot here also, cis. So here also I should write cis, (11 pi by 12). So like that I have completed this, okay. There is third one, z square, okay, let us do that. Yeah, z square. So z square means that just the two roots will be there, okay. One will be with negative sign, one will be 0, minus 1 and 0. So here what will be the modulus of this? Square root of 1 by 4 plus 3 by 4, 4 by 4, which will be 1. So therefore z square is equal to 1 cis, and what will be, it will be 60 degrees, right? So pi by 3. So cis pi by 3 plus k into 2 pi. How I got pi by 3? I got theta is equal to tan inverse root 3 by 2 over 1 by 2, root 2 and 2 goes, root 3 means pi by 3, okay, where k belongs to z. So therefore z is equal to square root of 1, or let me first write cis pi by 3 plus k into 2 pi, all of them raised to 1 by 2. So z is equal to 1 raised to 1 by 2 is 1, cis pi by 6 because divided by 2, and here k into 2 pi by 2, okay, k into 2 pi by 2. So I can write 6 pi by 6 because it was k into 2 pi by 2 and I want 6 in the denominator, so I will multiply by 3, so that 6 pi by 6. It will be easier for me to calculate. So k is equal to minus 1 and then k is equal to 0. So k is equal to minus 1 gives me the first root, says pi by 6 minus 6 pi by 6. So cis 1 minus 6 minus 5 pi by 6, okay. Yeah, are you following me? Minus 1 when I replace, So minus 5 pi by 6, and minus 5 pi by 6 is in the fourth quadrant. Okay, minus 5 pi by 6 is in the third quadrant, and in the third quadrant both of them are negative. So 30 degrees, so cos will be root 3 by 2 negative, and negative half I. Okay, and when k is equal to 0, z2, my second root, will be cis pi by 6 only, because k is 0, so there will be nothing here, so therefore only pi by 6. Okay, and pi by 6 will be positive, root 3 by 2 plus 1 by 2 I. Okay, let me write this properly, minus sign. Okay then, so to plot it, I will plot it here only. Yeah, so its radius is 1 unit. So one will be here and the other will be in the third quadrant, equally spaced, sorry, exactly opposite to each other. So here will be root 3 by 2 plus 1 by 2I, and here minus root 3 by 2 minus 1 by 2I. Okay, so I hope you will remember this. Now nth root of unity, let us find it out. I'll put it here because I have finished that there. Now look here, nth root of unity means to find the roots of 1. Okay, so it means we want to find actually cube roots of unity. I want to find, not the nth root. To find, let me write it here, cube roots of unity. Using nth root we are going to find this. Okay, so I hope you understood this. So it means we will find cube roots of 1. That is, to find cube root of 1 means we want to solve to find solutions of z cube is equal to 1. Okay, we want to find solutions of z cube is equal to 1. Now 1 is equal to cis, and because there is no imaginary part, so 0 plus k into 2 pi in polar form, where k belongs to z. This is the polar form, because always we write in polar form. Okay, and then therefore z cube will become cis k 2 pi. Therefore z will be cis k 2 pi bracket to the power 1 by 3, and 1 by 3 will get multiplied inside the angle, so k into 2 pi by 3. Okay, now here we are going to substitute k is equal to 0, k is equal to 1, and k is equal to 2. So when k is 0, z1 will become cis 0, right? Because this k will be replaced by 0. So cis 0 will be 1 only, because there will be no imaginary part. Okay, then k is equal to 1 will give you z2, second cube root, cis 2 pi. Now again 2 pi will be, k will be, sorry, I forgot to write 2 pi by 3, right, 2 pi by 3, and 2 pi by 3 is in the second quadrant. Okay, so it will give me the roots as minus half, because it is 60 degrees, so minus half plus root 3 by 2 I. Okay, and when k is equal to 2, z3 will be cis. Okay, k will be replaced by 2, so 2 to the 4 pi by 3, and now it is in the third quadrant, so both of them will be negative. So negative half and negative root 3 by 2 I. Okay, these are the, so therefore 1 comma minus 1 by 2 plus root 3 by 2 I comma minus 1 by 2 minus root 3 by 2 I are cube roots of unity. Now let omega, okay, because in terms of omega the relation is very important, root 3 by 2 I, then we will find omega square. So square of this side, so which will be 1 by 4 minus root 3 by 2 I and plus root 3 by 2 I bracket square, so which will be minus 3 by 4, because I square is minus 1. So I will write it on the next line. So 1 by 4 minus root 3 by 2 I minus 3 by 4. So this is going to become 1 by 4 minus 3 by 4 will be minus 2 by 4, which will be in turn which is going to become 1 minute, what I am writing here, wait, I, and when we simplify this, okay, so we are going to get minus 1 by 2 minus root 3 by 2 I. So look here, this we got by squaring the middle one. Okay, so remember that square of this is this and square of this will be that one. Okay, so therefore 1 omega square are cube roots of unity. Where omega is any one of them you can take, right? 1 by 2 plus root 3 by 2 I. Okay. Now I am giving you homework. Prove that one plus omega square is equal to 0, where omega is cube root of unity. Okay. Okay then. Now we will start the past paper questions, right? Yeah. So look at the first question, because I promised you I will solve at least 2-3 questions. So consider the complex number z is equal to w1 over w2, where w1 is this and w2 is this. Express w1 and w2 in the modulus argument form and write down modulus of z and argument of z. First we have to write it in the modulus and argument form, and then we have to write the modulus of z and we have to write the argument of z. Okay, so how can I write w1? Let me start first. Root 2 plus root 6I. Okay, so what will be theta here? Tan inverse of root 6 by root 2, and root 6 by root 2 will be tan inverse of root 3. Yeah, and tan inverse of root 3 is pi by 3. So this is the argument. So therefore, and what will be the modulus of this? Square root of 2 is root 2 square 2, root 6 square 6. 6 and 2 8, which will be 2 root 2. So therefore W1 is 2 root 2 cis, let me write, pi by 3, right? And similarly W2 also I will find. So for W2, 3 plus root 3i, theta will be what? Tan inverse of root 3 by 3, which will be tan inverse of 1 by root 3, and 1 by root 3 is pi by 6, 30 degrees. And modulus of W2, square root of 3 square 9 and root 3 square 3. So root 12 will be 2 root 3. 4 3s are 12. Okay. So 2 root 3 I am going to get here. So therefore W2 I can write in polar form as 2 root 3 cis pi by 6. Now I will write Z in the form of W1 by W2 using polar form. So W1 by W2, now W1 is 2 root 2 cis pi by 3, and W2 is 2 root 3 cis pi by 6. Okay. Now using De Moivre's rule, the modulus will divide each other. Okay. So root 2 and root 2 will cancel. Now root 2 by 3 by root 3 I will multiply by the rationalize the denominator root 3. So it will be root 6 by 3, right? And cis will get subtracted. So upper minus the denominator pi by 6. So the final answer is root 6 by 3 cis pi by 6, right? Okay. So therefore the first part I can write what they want, modulus of Z. Therefore modulus of Z, sorry, I will write directly modulus. So modulus of Z will be the modulus of this answer, this answer, right? Z I already got. Okay, star, let me write here star. So what will be the modulus? Root 6 by 3. We already have it in the modulus and argument form. And argument of Z, second part, we also have the argument for that, is pi by 6. So these are the two answers, right? Yeah. So I hope you will remember this. Okay. So this was the first part, A part. B part says find the smallest positive integer value of n such that z to the power n is a real number. It means there will be no imaginary part. So only the real part we want. So first let me write the nth root of z. Okay. So what we want, look here in B part, we only want a real number. So therefore when we convert this z to the power n is equal to, we already have here the polar form. So this into cis pi by 6. Okay. Now from this the imaginary part should be 0, because to get the real part only the imaginary part we want. To get only the real part we will take imaginary part is equal to 0. So that is sine of, okay, when I take the nth root, so z will be root 6 by 3 to the power 1 by n cis pi by 6n, okay, because it will divide by n. Sorry, here I should write n. Okay, therefore for only real part, yeah, are you following me? Argument of z, okay, from the argument of z to the power n should be equal to 0. So n into argument of z, sine of See, I will directly write. From this I can write sine of pi by 6n is equal to 0, isn't it? I want this part to be 0 because this is going to give me cos pi by 6n plus I sine pi by 6n, and I don't want it to be imaginary part. So I want only the real part, right? So this will be 0 when n will be, this n, where is my n? Oh, for z to the power n they said, isn't it? Not that one. So I will not take the nth root. Okay. So for z to the power n, my n will be in the numerator. Okay. Because here will be n, and this will, if z is this, then z to the power n will be n here and n here. Okay. So n pi by 6. Now when this will be 0, when n will be 6. For n is equal to 6, we are going to get sine of 6 pi by 6. 6 will cancel, and we know that sine pi is 0. So therefore the smallest positive value of n is equal to 6. Therefore for z to the power n to be real only, smallest positive value of n is equal to 6. Okay. So I hope you understood this also, this part also. So I'll go to the question number 2, right? Yeah. In question number 2, read it carefully. It says u is equal to 1 plus 2i and v is equal to 2 plus i. Okay. So given that 1 upon u plus 1 upon v is 6 root 2 by w, express w in terms of this. So we will start with the right hand side in the answer, A part. So 6 root 2 by w is equal to 1 by u. U means 1 plus 2i plus 1 by v is 2 plus I. Now we will rationalize them, or we will multiply by the conjugate so that there is no complex number in the denominator. Okay, here like this, and for this part I will multiply by 2 minus I. So I am going to get the denominator 1 square plus 2 square. 1 square plus 2 square will be 5, and numerator 1 minus 2i. Here also 2 square 4, 4 plus 1 5, and numerator will be 2 minus I. So both are together, we can simplify them together. So 5 and 1 plus 2 3, and minus, look here, 1 plus 2 3, and minus 2i and minus I is minus 3i. Okay. Now they want w. So therefore w over 6 root 2 is 5 over 3 minus 3i. Okay. Yeah, are you following me? So therefore w is equal to, this will go there and multiply. So 6 5s are 30 root 2 over 3 into 1 minus I. So this will be 10 root 2 over 1 minus I. Okay. And 1 minus I we will again rationalize. So 1 plus I mean we will multiply by the conjugate. So finally 1 plus 1 2, and 10 root 2. Okay. We'll have 1 plus I. Okay. So w is w in the form a plus bi. Okay. So we will separate them. So 10 root 2 by 2 will be 5. Yeah, here itself I can cancel it, so that I get the real part separately and imaginary part separately. 5 root 2 plus 5 root 2 I. This is in the a plus bi form. Okay, B part says find W conjugate and express it in the form R e raised to I theta, Euler's form we have to express it in. Okay, so W we already have, so W conjugate will be 5 root 2 minus 5 root 2 I, right? And then again we can write it in that form, so 10 can be out, so root 2 by 2 minus root 2 by 2 I, and then root 2 by 2 can be 1 by root 2 minus 1 by root 2 I. Okay, and if you want to combine them together, this will be cos of minus pi by 4 minus I sine of plus sine of minus I pi by 4, because minus sign I am taking inside so that I have the same argument with both of them, right? So this is so therefore W conjugate will be 10 cis minus pi by 4. I wanted to write like this because I wanted to have the argument separately. So therefore W conjugate is equal to 10. 10 is R e raised to I theta. I theta means minus I pi by 4 or minus pi by 4 I. Okay. So this is the answer of the second part. So I hope you understood this, right? Now the next question, third question, I will stop after the third question. Find three distinct roots of the equation z cube is equal to 64. Okay. Now we will start with that. Z cube is equal to minus 64. Now we will write it in the modulus and argument form. So it can be, look here, there will be no imaginary part. So we can use argument as pi. So I will write it as 64 cos pi plus I sin pi, isn't it? Because sin pi will be 0 and there will be no imaginary part. So therefore z will be, and I can write it in the form of cis pi. Okay, so z will be 64 cis pi, okay, cis pi plus k2 pi to the power 1 by 3. So z is equal to 4 cis pi by 3 plus k2 pi by 3, right? Yeah. And now I want the 3. Look here, they said giving your answer in the modulus and argument form, 3 distinct roots. So we want the 3 distinct roots. So for k is equal to 0, okay, here k belongs to z is an integer. So for k is equal to 0, k is equal to 1 and k is equal to 2, we are going to get 3 roots. So z1 4 cis pi by 3 only because k is 0. So cis pi by 3 we will write as it is. So giving your answer in the modulus argument form. So 4 and cos pi by 3 plus I sin pi by 3, right? I can write like that. Okay. And k is equal to 1. Z2 will be 4 cis pi by 3 plus k will be 1. So 2 pi by 3. So will be 4 cis 2 and 1, 3 pi by 3, which will be pi. And this I can write as 4 cis cos pi plus I sin pi. So this is in the modulus and argument form, and k is equal to 2. Z3 will be 4 cis pi by 3 plus this k I will replace by 2 now. So 4 pi by 3. So 4 and 1, 5 pi by 3, okay. So which will be 4 cos pi by 5 pi by 3 plus I sin 5 pi by 3. Okay. So this is in the modulus and argument form. Okay. So I hope you will remember this. Now B part. What they said in the B part? The roots are represented by the vertices of a triangle in an Argand diagram. Okay. Show that the area of the triangle is 12 root 3. Okay. So look here, we already have the 3 roots. So I will draw the circle, and this circle will have the radius 4, right? So real part here is 4 origin. Imaginary axis. Okay. Here is also 4, here minus 4, and here minus 4. Okay. Now where will be these 3 parts? So cos pi is minus 1. The first one is z1 cos pi by 3. Okay, pi by 3 will be in the first quadrant somewhere here. So I will join this. Force is pi by 3. I will write in short. Then second one is cos pi. Cos pi will be on the negative real axis. And third one is 5 pi by 3. 5 by pi by 3 will be in the fourth quadrant. So this is the C point. Okay, so A, B, and this will be the C point. So 4 says 5 pi by 3. Okay. Now we want the area of this triangle. Okay. Now look here, to find the area of this triangle, what we are going to do? Okay. We already have the angle, right? So look here, this angle is pi by 3, right? So pi by 3 and here is pi by 3. Then this angle will be how much? This angle will be pi minus pi by 3. Okay. So it will be 2 pi by 3, right? And then the here also we will draw one line, and this is also pi by 3 but negative pi by 3. So no problem. Okay. Okay then. So to find the area of this triangle, look here, we will find the area of 3 different triangles. Okay. We will take each triangle. Let me mark it with different colors so that you can see them. See, one of my triangle is this, the other is this, and the third is this. So area of 3 triangles will give me the area of the whole triangle. Okay. So how will be the area of the 3 triangles? Yeah. So for area of 3 triangle, each side is 4 because the radius is 4. Okay. And the angle between them is pi by 3 plus pi by 3, 2 pi by 3, right? So therefore, area of triangle ABC will be 3 times area of one of the triangles. So one of the triangle we will use the area formula 1 by 2 AB sin C. Okay. So 1 by 2, A is 4, B is also 4, sin C is 2 pi by 3. Okay. So this will be 2 will cancel with 4, 2, 4 to the 8, 8 3 is 24. Okay. And 24 sin 2 pi by 3. Okay. So it will be root 3 by 2, right? And therefore The final answer is 12 root 3. This is the final answer. Yeah. So I hope you understood this also. Right. Question number 3. So with this then we will stop here. Okay. So I hope you liked this lesson. There were bit lengthy parts, but in 1 hour and 5 minutes I have completed this lesson. So okay then, I hope you enjoyed this lesson. Okay, if you have any suggestion, please contact me on my email ID or on my WhatsApp. The PDF of this explanation file, its link will be there in the description of the YouTube video. Okay, please like, share and subscribe my channel. Okay, okay then, bye for now.